Okay, good morning everyone. I hereby open this academic ceremony in which Zhanzi Liu will defend the academic thesis entitled Body Perception in Social Environments, the Neural Basis of Body Expression Perception in Social Threat, Social Interaction and Self-Identity. May I invite the candidate to present a summary of the thesis and the conclusion of your work.
Highly estimated opponent, supervisors, dear colleagues, friends, and family, thank you all for joining me today, either in person or virtually, for my defense. I will guide my thesis titled Body Perception in Social Environments, the Neural Basis of Body Expression Perception in Social Threat, Social Interaction, and Self-Identity. Over the next 50 minutes, I will introduce my thesis, which focuses on the main topic of whole body expression. Whole body expression can be observed everywhere in social environments. When we talk about whole body expressions, what can it convey? Humans are social beings. An important skill for humans is the ability to recognize and perceive others' emotion, like face and voice. Whole body expression can also convey emotional information. For example, when you see a man raises his hands into a fist, you may know that he is angry. This angry body expression can elicit the perception of social threat. And this emotion perception is not only observed in single agent, but also observed in dyads during social interactions. When you see two people, they appear angry, you may know they are fighting or they are interacting a conflict. In addition, when you're facing a mirror, you can recognize it is yourself. Even though without facing a mirror, you can identify yourself through pictures, which refers to self-identity. Based on this information that body can convey, in the next 3 chapters, I will introduce how body perception, body expression perception, modulate the brain activities. And 2 of these cooperate with VR and combined with the high time resolution technique, EEG. Before start chapter 2, I will briefly introduce an important term, ERP. ERP is also called event-related potentials. They are brain potentials time-locked to a sensory, cognitive, or motor event. A previous study found that both inverted face and body stimuli elicited the larger N170 ERP amplitude than the upright face and body, which indicates that the N170 here is more sensitive to inverted stimuli than the upright stimuli. And moreover, we can learn that the N170 is not only related to encoding face stimuli, but also related to encoding body stimuli. Now we start chapter 2. There are 2 kinds of threats, non-social threats, such as animals and guns. Social threats, such as angry face and angry bodies. A previous study found that participants' response time was shorter when they saw the threat stimuli compared to the neutral stimuli. And an ERP study found that the threat stimuli elicited the larger early ERP component, such as N1, compared to the neutral stimuli. As a human being in social environments, the social threat is a very important kind of threat. We may have the ability to control the threat. While how the controllability impacts social threat is still unknown. So in this chapter, we explored the neural basis underlying social threat and how the controllability impacted it. Participants underwent a VR environment. They first saw a controllable cube, and then a static avatar, either with angry body expression or neutral body expression. 1 second later, the avatar started approaching. Participants can press the button to make the avatar stop. But whether the avatar stops or not is according to the cue at the beginning. There are 5 kinds of queue from 0% to 100%. For example, is to stop the avatar approaching if they press the button. Then we found the distance between participants and the avatar. It was larger when they saw the angry avatar compared to the neutral avatar. In ERP results, we found that N170 was enhanced when they saw the angry avatar compared to the neutral avatar. N170 is an early ERP component occurring around 180 milliseconds in temporal regions. As I just introduced to you guys, previous studies found it is related to face encoding. Here, we found it is also related to body encoding and more sensitive to social threat. Then we found that angry avatar elicited a smaller N3 amplitude than the neutral avatar. N3 is a mid-late ERP component related to cognitive resources. We found N3 here is sensitive to social threat and suggesting that processing of the threat required additional cognitive resources. From Chapter 2, we learned that social threat is detected rapidly as reflected in a body emotion effect on N170. We didn't observe any interaction effect between social threat and controllable queue, which indicated that processing of social threat is independent of the observer's ability to control the threat. In Chapter 2, we found the body emotion effect based on single agent, but we still didn't know, does this emotion effect also occur in dyads, which means 2 agents during social interaction? So in this chapter, a previous study used the dyad stimuli to explore the emotion perception based in social interaction environments. As we can see in the picture, an avatar approaching another avatar and tapping his shoulder, either with angry tapping or neutral tapping. Then another avatar reacted either with angry body expression or neutral body expression. They asked participants to judge the angriness on the approaching avatar, and they found that perception of a single agent simulation, which means the perception of the approaching avatar is impacted by the social interaction of the dyads. In Chapter 3, we used similar but more realistic stimuli. We first present the participant the video showing the person on the right approaching the person on the left, either with angry typing or neutral typing, as we can see the video here. And then we show the still image showing the reaction of the left person, either with angry reaction or neutral reaction. There is a short gap between the video and the image to elicit the social prediction on participants. When the emotional context of both the video and the image they are congruent, participants need to judge if the reaction of the left person matches the reaction. If the reaction of the left person matches the action of the right person, when the emotional context they are the same, then the correct answer is yes. But when the emotional context is incongruent, then the correct answer is no. Both congruent and incongruent refers to prediction error. In addition, we want to manipulate the social context of the video in parallel. We show the high prediction condition which places the video as normal one, as we can see. And we also set the middle prediction condition. We play the video backwards. And in the low prediction condition, we play the video scrambled. Then we found the accuracy. There is a leaning effect on the accuracy. It was the highest in the high prediction condition, and then the middle prediction condition, and the lowest in the low prediction condition, which indicates our social prediction manipulation was successfully. Then in N170, our results was in line with Chapter 2. we found the angry reaction elicited a larger amplitude than the neutral reaction, but this body effect was only observed in the high prediction condition when the video was clear and intact, which indicated that emotion influenced N170 amplitude, and this emotion effect on N170 depends on the prediction strength. We also found that incongruent response elicited a larger N300 amplitude than the congruent response, and this prediction error effect was only observed in the neutral reaction, and the N300 here is related to violation and the prediction error, which may reflect that participants maybe feel more violated when they saw the incongruent response. And this effect depends on the emotion expression in the whole body interaction. From chapter 3, we learned that reducing the emotional cues in the video led to a significant decrease in participants' ability to correctly judge the appropriateness of the emotional reaction in the image. And viewing the initial stage of social interaction triggers predictions about the outcome in the early cortical processing stages. As individuals in social environments, perceiving ourselves is also crucial to our health and well-being. While most studies have explored self-identity through facial expressions, only a few studies have examined self-body identity or the integration of self-identity across both face and body. So in this chapter, we designed a novel paradigm. We generated the personalized avatar, as you can see in panel A, the self-identity avatar, whose face and body are the same from participants' own face and body. And then we generated the other avatar, whose face and body are totally different from participants' own face and body. These two avatars refers to our main condition. In addition, we set the control conditions. We modified the body from the main conditions, which called the self-face with big body and the other face with medium body. Participants first underwent the VR environment, and they did the embodiment task on one of the 4 avatars. And then we show the avatar images on the screen and recording their EEG signal. We also tested the embodiment scores, identification, and liking scores on each avatar. And we found that participants embodied and liked more the medium body, more like their self-body than the big body, regardless of face identity. And in identification score, we found that face identity alone is not sufficient to trigger self-identity perception. In N170, we didn't find a clear effect of self-identity. While in N2, we found self-identity elicited smaller N2 amplitudes than other identity, but we didn't observe any effects between control conditions, which indicated the suppressive effect of self-identity perception on N2. From chapter 2, we found that body identity plays an important role in self-identity. And the early N2 component is related to self-identity processing. Taken together, body expression plays an important role in social environments. And the N170 is a useful neural marker of body expression perception. Thank you very much for all your attention. I hereby give the words back to Prorector.
Dear candidate, thank you very much for your presentation, which was perfectly in time. And now we will start the opposition phase of the defense. And the opposition will be started by Professor Milene Bonte, which is Professor of Cognitive Neuroscience of Language and Literacy Development at Maastricht University.
Dear candidate, first of all, I would of course like to congratulate you and also your supervisors with this great achievement. And as you explained in your very insightful presentation, your thesis investigates emotional body perception in different social contexts, right? And you use different behavioral and EEG measures and virtual reality to come as close as possible to real life perception of body expression. And so this research is not only scientifically very interesting, but also has great societal relevance and practical implications. So congratulations for that. But of course, I also have a couple of questions, right, after reading your thesis. And I would like to first focus on chapter 2, where you use EEG and VR to study social threat perception under different levels of perceived control. And your conclusion is basically that actually the perception of social threat and control are independent, right? Yes. And that is a bit surprising, right? Also because in your introduction you explain that you expect actually an interaction. So you expect that there would be stronger social threat effects in case of reduced perceived control, right? But you don't find that. So maybe let's start very general. Can you think about reasons in your design or in the experiment why there was no interaction?
Highly estimate opponent. Thank you for your great question. Yes, I thought about it after we got the results. I think there are several reasons. One reason is because maybe the number of participants is only 26. So that's maybe a reason why we didn't find a clear effect or interaction effect on the control ability. The second one, I didn't report here because of the time limited. Actually, we found an effect of the control ability on the later LPP-ERP component, which also indicates that the control ability can impact the evaluation of people how to judge the ability to control. But we didn't observe the interaction effect. In reality, I don't think it means that it's really independent. I think people still have the ability to control the social threat, but maybe because our lab environment is not a real life, is close to real life, but not a real life. So we didn't observe the effect on the brain activity. But I believe people can control it.
And could it be, yeah, that's very clear. And could it be also related to the fact that you calculated your ERPs only for the static avatars and not for the phase where the avatar could be approaching? So is it possible that participants knew kind of or realized or at that time didn't process yet the control ability?
Yes, exactly. Yes, because participants, they know they in the later, in one second later, they can control it. But our ERP tested in the first steer stage, so they maybe like you just said, it doesn't impact the early one. It maybe impacts the later one.
Yeah, exactly. And could that also then? I was actually thinking in your chapter, maybe you did in your data, you did find some type of interaction, because when you look at the plots of the theta power, right, theta power,
yes,
there you see actually that the 75% condition shows the largest difference between the threat and neutral phases, right? And then you also see it a bit for the 100%, but not for the others. And so in principle, or percentage controllability, right? So in principle, could that relate to predictability? Because in your chapter 3, you say you find you only find body expression effect in the high predictability condition, and your 75% control and 100% control, they are more predictable.
Yes.
Right? So could you comment on that? Can it be that you did find an interaction?
In statistic, I didn't find the interaction.
Okay.
But as you observed, maybe we needed to enhance or enlarge the population to test more.
So also this effect on the theta wave, the theta power, I don't have your
in
booklet
chapter
here,
2, I remember.
Yeah, that there's no interaction between the controllability and
Yeah. We didn't
Difference.
observe in statistics.
Oh, okay. Yeah. Okay. So in that sense, you're right. Then, if you would have more participants, you could, in principle, get this out statistically. Yeah, that's true. And then I had another question, actually, about this controllability effect, because you, in your ERP, you show that only for the 100 versus 75%. And I was wondering how do the effects look for the less controllable conditions, like 0, 25, and 50?
You mean the ERP in LPP? In my memory, the results should be 100%. It means that fully control elicited the larger LPP than the 75. Maybe because the 100% control, participants have more motivation to control it, because they know for sure I can stop the avatar approaching. So like 75%, we can also regard it as an uncertainty percent. It's not a 100.
Yeah. And how did the signal look like? Because in your figure, you only show, for the LPP, you only show 75 and 100?
Yes.
What did the signal, do you still remember? What did it look like for the less probable conditions?
Yes, previously I plotted 5 lines. Then it looks like a very complicated.
Yeah.
So then finally I clean the others, only keep the ERP's conditions which have effects.
Ah, okay, yeah. And they looked then more similar to the 75, or you don't, or it was kind
I
of...
can't remember clearly,
Okay.
but 100% is the highest one.
Yeah, exactly. Yeah. Okay. And maybe then to move a bit more general again. So if on the hindsight, of course, in any experiment that you do, right, on the hindsight, you always think, I could have improved this or that, because that's how science works, right? So if you think about this specific paradigm, what would you change if you were given the money to redo the experiment?
First of all, I will reduce the Q. Like we have 5 conditions here, which is very good. We can test a different level, but maybe in the brain, it can't distinguish the minor difference from 0 to 100%. First, maybe I will reduce it into 2 or 3, like a certain or uncertain, like or 0, 50% or 100%, to see the, maybe people can feel the larger differences between them. And then I think we have the limitation of the study. We didn't take the advantage of VR as you just suggested. We didn't fully use the long term of the dynamic avatar. Then in the next analysis stage, I think we should consider how to get clean EEG and analyze the dynamic avatar.
Yeah, that's very interesting indeed. And then if you would take it even another step further, in your discussion you indicate that you would like to apply these type of paradigms to clinical populations. So do you have already some concrete ideas how you would do that?
I think in the clinic, it may be, in my opinion, it may be useful for the domestic violence, people who suffered the real social threat from their family. They maybe have the more real feeling when they engage in the VR environment. So for me, this part is also meaningful to test the different sample in the clinical group.
Yeah. And in that case, would you use the same type of stimuli, or what would you?
Similar like body expression, I think is close to our life.
Yeah. And then still in this alley kind of. And what would you expect then, actually, if you have this? Okay, say you use the same paradigm. Would you expect a stronger interaction between social threat and controllability, or a less strong?
I can't say. I also are including the real situation and add more question layer, such as how long they have been suffered from the violence, and who did the violence for them and their childhood experience and others. And then I think I can get a conclusion, but now it's difficult for me.
Yeah, sure. Yeah, yeah, that's clear. I think. Thank you very much.
Okay, then the opposition will be continued by Professor Jan van den Stok, Professor of Affective Neuroscience at KU Leuven.
Dear candidate, first I would like to wish you a Happy New Year, Chinese New Year, if I'm correct. And secondly, I would like to join my colleague in congratulating you on a very impressive amount of work that you have done for your PhD, and also I'd like to congratulate your promoter team. I can firsthand testify how pleasant it is to work in under the supervision of your promoter, and how inspiring the collaboration can be. I was also very impressed by the diversity in your methods that you used, particularly, but not only in the inclusion of virtual reality in your work, which I think is a very promising technique for the future, and it's very inspiring to see that you are doing pioneering work in this area. And I think the applications are multiple for scientific work, but also in the clinic, as you have also discussed in your thesis. I also have some questions. Maybe first I would also like to, before going to that, congratulate you on the publication of your first chapter in a journal with a very high reputation. Congratulations for that. I will move to the questions now, and maybe start with chapter 3, where you focus on predictions, or where you try to manipulate the prediction error. So first I was wondering, so I assume then that one of the assumptions or perspectives that you took to set up the study related to predictive coding.
Yes.
Could you maybe try to formulate what you understand by predictive coding?
Highly estimated opponent, thank you for your excellent question. If I understand correctly, your question is about how can I state the prediction error effect, right?
Well, maybe my question is more like, how would you define predictive coding?
In the term, define the...
Yes, what does it mean?
Okay. In our design, the prediction error, which refers to participants, first they saw the video, emotional context on the video, and then the emotional context on the still image of the reaction. And the prediction error here mainly refers to if their emotional context is incongruent. Like you see a person attaching you with angry, then you reacted with a neutral one. You may have the strong violation that, oh, maybe the person did the wrong reaction or others. So that's I will define.
Okay. So do you have any hypothesis about the brain regions that would be related and to generating these predictions?
Yes, because the prediction error, in my mind, it maybe refers to more higher cognitive stage. So it should be maybe in the frontal or central area, because EEG doesn't have the exact the space resolution, very high resolution. So we took the lectures and averaged, such as we just saw in the N300 effect. It mainly shows the prediction error effect, and then the lectures are taken from the frontal central area.
Okay. Do you think it might be related to because prediction error is a term that stems from a reward, the research on reward, and was mainly reported first relating to the dopamine release, to expected versus non-expected rewards in the ventral striatum. Do you see any connection with that finding and your findings?
You mean the term of prediction error is from the reward experiments, like people, they expect to get more money and then less money, they get feedback, right?
Or maybe do you think congruent or incongruent conditions in your experiment might also be linked somehow with reward?
The rewards, I'm not sure, actually, because the rewards, as I understand it, mainly in our psychologist methods, is mainly related to the money rewards, like people get money from the experiment, or the social rewards. I'm not sure if you mean that. Mm-hmm. Yes, but for us, it's mainly related to you see the reaction, which is well related as you expected. So I'm not sure. I can't guarantee they have the correction or correlations.
Okay, thank you. I was also wondering, were you involved in the construction of the stimuli for experiment 3?
Sorry, I can't fully understand what's the construction stimuli.
When they made the stimuli, when they made the videos of the actors, do you have an idea about the specific instructions that were given to the actors?
This question, I used the stimuli from our lab. Okay. And our lab asked the actors to do it. And also, as I just introduced, there is a paper about the avatar. I'm not sure if the audience remembered. They also have the avatar stimuli, which is actually same or similar to our stimuli. The avatar approaching another avatar, and another avatar reacted to the approaching avatar. So they already published and get a reliable results. Our stimuli used the similar, but I think also realistic one.
Could you maybe go to the slide where you show the design of experiment 3?
Here, right?
Yes, I was actually looking for the timings. I don't know.
The timing. This one or later one?
No, of the stimuli.
Of the stimuli. Okay. The video, the timing of the video.
Yes.
Is within 1 second, around 500 milliseconds.
And then you had a blank screen, if I.
Yes.
Yeah.
As
of
you
500
can see
minutes.
Here, a blank screen. I can't remember exactly. Maybe around 400 to 500.
Mm-hmm. Do you remember why you chose that duration for the blank screen?
The blank screen, first is randomized the interval to reduce the ERP expectation effect. And then I think this short gap can allow participants to connect the previous one to the later one, so it shouldn't be very long. But it also shouldn't be impact the ERP in the still image.
And do you think the duration of the blank screen might affect the strength of the prediction error? I mean, do you think if you would have shorter duration of the blank screen of the interval, would it increase the prediction error in the incongruent conditions or decrease?
I'm not sure what do you mean, how long? For example, if it is 1 second, then it's too long. Then participant, maybe they don't remember or they can't react on what I just see in their brain. So they only process the first stage, not the later one. If it is too short, then it seems like we only present the video, not the still image. They don't have time to elicit their social prediction here.
Okay. And so your results showed that there were that the accuracy was similar between the congruent and the incongruent conditions.
The accuracy, we only found the effect on the prediction strength. We modulate the video.
Yeah, so there was no difference between congruent and incongruent, right?
Yes, we didn't find the effects between congruent and incongruent. Sorry, but that is good, which means our the task of difficult, they are the same between two conditions.
Well, I was wondering, did you also analyze the reaction times for the responses?
Here, we didn't analyze the reaction time because we didn't encourage participants to press the button as soon as possible, because it may be, in fact, their ERP results in the still image.
And do you have any hypothesis about the reaction times? Would they be similar in the congruent and incongruent conditions?
That's a very good question. Actually, we did the behavioral task in advance of the EG task, but I didn't count it here. In that task, we encourage participants to press the button as soon as possible if they are sure about their question. Then we found the task difficult between the accuracy effect between the congruent and incongruent. The incongruent, the response time for the congruent is faster than the incongruent, which also indicates that participants expect to see the congruent one, and the incongruent one maybe take more resources from their brain.
Did that result impact your decision not to include speed in your instructions for the ERP experiment?
Yes, exactly. Yes, in that behavioral experiment, we wondering it may be in fact the ERP effect. So we didn't encourage them in the later experiment.
Okay. Relating to this slide, if I read correctly in your thesis, you found that for each of the three conditions, the accuracy was above chance for each of the three prediction strength conditions?
Do you mean which conditions above chance?
For each of the three, they were above chance level, right?
In the low level, it's similar to the chance.
Okay.
Here.
Because that was my question, indeed. That how could you explain that in the low prediction strength condition that the responses are above chance? Because there is no conceptual information contained in this condition.
Yes, but I think here we found it similar, the low prediction condition. It has the similar, like the chance level, which is very good, which means participants didn't observe the useful social information. So we only have two choices, match or not match. So they can randomly choose one if they don't know the exactly answer.
Okay, thank you.
Yes, thank you very much. And the opposition will be continued online by Dr. Lars Ausfeld, Assistant Professor in Naturalistic Listening at Maastricht University.
Good. Thanks, Director. Dear candidate, dear UNC, also from my side, congratulations to this really interesting piece of work. Also, congratulations, of course, to your supervisor team. I think it's also, and there I chime in with the others from before, it's really pioneering work, trying to really get as much into real life situations, and especially for this type of research that you are doing, I think this is really, really important to approach the real life situations here. yeah, also, I have to ask some questions, of course. I would like to start with a bit more of a general question. So, in a study that we were doing, which was a very basic attention network task, we found something interesting if we compared standard delivery of the task, meaning just on the monitor and the participant responding as usual. If we move that, when we move that to the VR condition, so basically we present the same task, but then in a more or less fancy apartment, also there on the screen, we found something interesting in the sense that certain effects which relied on arousal were not there anymore. So that means just being, at least that's how we interpret it, is that simply being in a VR environment means that you are a lot more engaged with the task, and that might actually move up the engagement, the arousal of people while they're performing the task. So I was wondering whether you think how reliable, or basically how generalizable is the result that you, for example, see in the VR study, chapter 2 of yours, compared to real life. So I'm not sure, maybe VR could be something like a novelty factor, right? So that people are excited, yeah, I'm in a VR environment, that's super nice, I've never experienced that. So they are just a lot more engaged in the task in general. So I would like to know from you, so how much do you think do these results that you have, how much do they translate into real life situations?
If I understand correctly, your question is about general how the VR environment is close to our life, right?
Yes. Yeah.
Okay. I think that's a very great question, and also I think in our lab environment, the biggest challenge is about how all the situation is close to our life. But in VR, I think it's more realistic because it has 3D environment, and the people may feel more real than a 2D world, like you just see pictures or videos on the computer. And also in VR, we allowing participants to freely investigate the VR environment. And finally, in all the VR experiments, finally we tested like the embodiment, how real you think of VR is, something like that question there. And in my memory, all the results should be about the media level, like a 1 to 7 Richter point scale. There should be above 4. So it should be have more realistic than what we see in the 2D computer.
Mm-hmm. Okay, so that means you are not worried that basically being exposed to an VR environment might actually add something like extra to real life processing. So you think that basically VR actually is a very good way of capturing real life, and it does not add anything additional to to how we process, for example, these social threat stimuli that you were using.
Yes, but it's still very difficult to the real life.
Sorry, can you repeat that, please?
I think it's still very difficult to the real life because participants know that they are doing an experiment, but maybe better than the computer task.
Mm-hmm. I think, at least personally, I think that it's a very interesting question to answer, right? So it could be that in real life we are in general more engaged in such a situation. So I mean, if I see somebody approach me in a dark alley that you have there, I don't know whether I would be calm and just wait. And so I think I would also be probably a lot more aroused in that situation. So I think it's an interesting question to actually follow up on, I would say, to compare VR maybe to real life and maybe laboratory experiments. Okay, then I want to move on a bit, and I wanted to ask you about the analysis here, basically for chapter 2, but in the end it also holds for 3 and 4. So you are, because you're using ERPs, you kind of have to limit yourself to responses to static stimuli. Do you think, also that relates a bit to Professor Bonte's question, do you think being able to maybe analyze also dynamic stimuli with EEG, whether this could actually help you to maybe find out more what happens dynamically during the situations? So there are now certain newer analysis techniques that allow to actually analyze these dynamic stimuli. So where you don't need any more like one image at a certain point in time, but where you actually can present, for example, in my case, it's always audio or like sounds, which are inherently dynamic. But in your case, you're presenting videos, which also have very dynamic features. So do you know about these techniques, and do you think it would actually be valuable to the studies of yours and maybe to the data to look at the EEG responses while watching the video or watching a dynamic scene?
Great question. Yes, I think this idea is very good. We should consider how to analyze the dynamic stimuli, but I think we shouldn't use the ERP, because in the dynamic stimuli, every frame they changed, like you use the audience. If it is a short one, like 200 milliseconds, ERP works. But if it is a very long one, like 1 second, ERP maybe still works. We can find the effect, but we can't guarantee the effect is from which frame, because every frame changed. So in my mind, I think we can't get a clean ERP here. Maybe use other methods to analyze the EEG data, like brain activity, or like others, it may work.
Mm-hmm. Yeah, that's I guess also a bit why you went into these oscillations. Maybe that could become something like an interesting endeavor. And then there are also some multiple regression models, which actually can take certain features from a dynamic stimulus and try to fit the EEG data over a certain amount of time to these dynamically changing features. So I think I don't know. It could be an interesting endeavor, but I guess you would actually need to prolong a bit the amount of dynamic stimuli. So maybe the person in the LA has to be slower or has to start a bit further away or something like that. Okay. Good. Then maybe I have a very short question on the methods. I like that you are very consistent across the chapters in terms of how you analyze the data. I think that is usually a sign of good data quality and not making basically result-based decisions or result-based decisions on the analysis. I was wondering about the removal of independent components, which in your case you have a 64-channel layout, or then using maybe some less because you have additional signals that you're measuring. So to my experience, you're removing very, very few components, meaning 1.8, 1.5 in chapter 2 and chapter 4. So I was wondering, how did you manage to do that? Because usually we remove these components because these are artifacts. So does it mean that you didn't have that many artifacts? I don't know, did you maybe try out what happens if you remove maybe the final, a bit more noisy components, which are always there in these situations? So can you maybe briefly comment on that?
Sorry. If I understand correctly, do you ask me how I choose the lectures for the component or other? Or
yeah, how did you select the components to remove? Because these are really, really few. I think I can hardly imagine, or I don't think I remember a case for a data set where I removed that little independent components for cleaning or for cleaning EEG data.
In our methods across the 3 chapters, the methods mainly we look at previous papers to see how they choose the ERP component from which lectures or which area, and then follow their method. We choose our main dominant ERP component at the certain window and the certain regions, and then we choose the peak amplitudes and make it at the middle.
May I interrupt you there? So I think you're now describing it how you chose the channel clusters basically. My question was a bit more about independent components, but I think I'm already over time from what I think. So I would thank you very much for your responses, and I give the word back to the prorector.
Yes, thank you, Dr. Hausfeld. And yes, in fact, it's good that we move on. We have another opponent on the list, and the opposition will be continued by Dr. Marta Pollo Solanas. There is a researcher at Maastricht University.
Thank you. Dear candidate, dear UNG, I would like to join the rest of my colleagues in congratulating you for a very nice and clear presentation, but also for a very well-structured, well-written, and excellent thesis, and extend my congratulations to your supervisory team, and specifically because of the contributions that it makes to social and affective neuroscience by specifically looking into how we process nonverbal signals, specifically from the body, which have often been sidestepped in this field. But of course, I also have some questions for you. I would like to start by chapter 3, where, as we discussed, and we have also seen in the presentation, you investigate whether we are able to predict the outcome of social interactions by first presenting a video, and after a short period, you present the last frame of this video, right? And this last frame could be matching or not matching to the video in terms of balance. But I'm still a bit concerned, or I would like your input about the prediction strength condition. So you have 3 levels of this condition, right? So high, where you present the normal video, so how it is. Then mid, where you present it backwards. And then low, where you basically scramble each frame on this video. And in the abstract, you say, we vary the strength of the induced predictions by parametrically reducing the saliency of the emotional cues in the video. But I was wondering if this is actually the case, if you are just varying the emotional cues or something else, and if this was meant to be a linear reduction as well. I mean, we can see here in the slide that indeed you reduce the prediction, but I wonder if it was the emotional cues that you were reducing or something else. So if you could maybe elaborate a little bit on your choices here.
Highly estimated opponent, thank you for your excellent question. Yes, we manipulate the social cue. You can also call emotional cue. Here, in the normal one, as you said, we play it as normal. So the movement and the emotional context, they are very clear to participant. So we think it is belong to high condition. And then in the middle one, we only manipulate the movement, but participant can still recognize the emotional context here. And then in the lowest one, we not only reduced the movement, but also reduce the emotional context here. So in the design, we think it was manipulated in parallel. As you just introduced our results on the accuracy, it also reflected that our manipulation was in linear.
Mm-hmm. Yeah, I have indeed no doubt that you manipulated prediction. It was more about how you manipulated the emotional cues, because you mentioned that it was parametrically targeted to the emotional cues. And for example, in the mid condition where you played backwards, you say that you manipulate movement and emotional cues, but I feel like by the design that the kinematic and postural features of these movements are still preserved, that very much relate to emotion, and maybe then you are not really manipulating this, but just is temporal continuity that you are targeting here, for example. And in the low condition, you you scramble, and the emotional cues probably are very much impacted by this, but for example, maybe the motion energy is still preserved, which is a kinematic feature that has shown to be very relevant in discriminating between emotions, specifically between anger and a neutral condition. So can you maybe elaborate a little bit about this?
Yes, in the middle one, as you just introduced, we only manipulate the movements. The emotional cue is still there. And in the lower one, as you also noticed, and we also can, maybe participants can also recognize the emotional by the movements, because in the scrambled one, not whatever we can control the stimuli, the movements is still there. Otherwise, if we make it more scrambled, it seems like a still image. But still, from our results, the accuracy on the lower one is close to chance, which also indicates that the participant, they may need to guess they are match or not match.
Okay. And just out of curiosity, now that you have finalized the study, would you change anything about how you modify this prediction strength in the videos? Would you keep it the same, or?
It's a very good question. But in our case, it's according to our research question, because our research question here is about social prediction, how it impacts the body perception, body emotion perception here. But if we change another research question, like how we perceive only social prediction, not the how it impacts the emotional condition. Like we only use the video, we don't give them any later one, we don't show their image. So maybe we can add more manipulation on the video, like make the time scrambled. Like every frame, they randomly presented. And also other manipulation of the video, and to see how the social prediction impact the perception on participants.
Okay, thank you. Then I will move to my second question. That is, that basically concerns the effect of task dynamics on behavioral and neural responses. So we know that neural activity can change depending on the task at hand. And we know in the lab we have shown this by the effect of task in how we process bodies in the stress-treated body area. So in chapter 3, participants are directly asked about the appropriateness of the final frame following the video. And this task is closely tied to the aim of the question that you are investigating. So I was wondering if you expect to observe similar ERP results or behavioral results, given that this task is such a cognitive reflection of the social interaction, or if you believe that we process social interactions in an automatic way, and therefore maybe the results wouldn't be that much affected.
I'm not sure if I understand your question correctly. So you mean how the paradigm of the design impacted the perception of social interaction?
Yeah, specifically the task. So if you would expect by using, because in the task you ask a question to the participants that is very much related to the research question, right? So you make them think about the outcome of this final frame. And I wonder if you would see the same results if you would ask, if you would use a different task or passive viewing, and therefore if we can see these results reflecting a more automatic process that is regardless of the task that you use.
Okay, relating to the automatic processing, right? Regardless of the task, I think at least in the early stage, as our brain reacted, I think in an early stage it should be reflected the automatic processing of the body emotion. As we can see through the 3 chapters, we found the N117 is related to encoding emotional body, especially it enhanced by the more emotional body like angry body. So it, in my mind, it may be related to the automatic processing.
You're happy? Yes, good, good. Dear candidate, the time appointed for defending your thesis has passed. The degree committee will now withdraw to discuss the quality of your thesis and your defense. I request that you and your company await the results of the deliberation and our return in this room. Thank you very much.
The PhD defense has now ended. The degree committee will debate the candidate's performance behind closed doors. This process usually takes about 10 minutes.
Long road to the south side. 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and die. All your time, 'cause I'll go the extra mile. Long road to the south side, 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and die. On the dash, got my laces tied. Long road, I don't waste no time. Break rules because fate decides. With the team and we chase the light. I make a move, fall down, shake it off. I hate to lose, bad branch, break it off. No room for negativity, praise and love. Prepare for deep part cause we're taking off. Take the mileage, traveling so far from home. Gathering knowledge, other connections. I put the time in to get everything I ever hoped for. It's a challenge and we all in. It's a better future that we go for. Even though these nights seem long, I know that I am never on my own. Know you won the battle once you grow. South side, 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and die. Long road to the south side, 10 miles in my rearview mirror, I know what it felt like. My goal's only getting clearer, east side to the west side. No place like home, if it's questions that you've got, go the extra mile and die. Years can't fly by now, don't waste all your time. 'Cause I'll go the extra mile.
Dear candidate, dear Janzi, the degree committee here present has assessed the quality of your thesis and your defense, and in view of its positive verdict and taking into account your previous qualifications, the degree committee has decided to grant you the degree of doctor. Professor De Gelder is authorized to confer upon you this academic distinction in accordance with Dutch university customs, and I invite your supervisor to now take the floor.
All right, please. Dear Guenci, do you promise to work in accordance with the principles of scientific integrity at all times, to be careful and honest, transparent, independent, and responsible?
Yes, I promise.
Good. Then we can go on. By the authority vested in us by law and in conformity with the decision of the committee here present, I hereby confer upon you, Guenji Lu, the degree of doctor, and grant you all the rights attached by custom and law. As evidence of this, I now present you with the degree certificate signed by the rector, the secretary, and the other members of the committee, and affixed with the official seal of the university. Dear Guenji, here we are, at the end of a road. It was not too long, actually, it was a bit shorter than expected. But you did it very well. We all admired and appreciated your defense and your clear exposition of the thesis, of the different chapters. We were all in full agreement that you give a very, very clear and very to-the-point response to the different questions, which is not all obvious, as you see. Questions come from different angles and address different aspects of the thesis. You've been in our group for a bit over 4 years now, and one thing that the first thing I want to see, you've always been a very loyal member of our group, always open-minded about whatever suggestions came along and collaborating with other people. So that's really, really appreciated. If I think back about those 4 years, then one thing that strikes me in concerning your personality, should I say, your persona is nicer than, a bit more general than personality, is your motivation. I mean, PhD students come and go, and I've seen a number of coming and going, so in that respect. And you could say that you characterize them on various continua, but one continuum to be sure about it is their motivation. Like some PhD students, you have to remind them every day, how is it going? Is something going to happen? Will you start testing? Other ones anticipate even the question, and on that continuum of from motivational continuum, you really are at the extreme. I mean, you have been extremely responsive in whatever we suggested, whatever Lars and I came up with as approach, as pilot testing, as quick analysis of the results, as continuous, as gathering subjects. You're known as being extremely efficient, careful, but fast in collecting subjects, in looking at different data analysis, etc. So we're really, really very happy to have you here. Today is the beginning of the new year, which for you and for us, I celebrated already at the Chinese embassy yesterday. That's a different story. And it's very funny, I was surprised, because it's the year of the serpent, and in Western culture, the serpent is somewhat ambiguous. I wouldn't say it comes across as like a very positive sign, but in China, it's a very positive thing. You shed your new skin and a new life starts. So I think it's absolutely marvelous that on this day, we can celebrate your PhD. And I wish you stay with us for a bit longer, which is very good. I wish you a beautiful, beautiful life. And now, Lars can continue.
So, yeah, Janzi, also from my side, big congrats to this achievement, also for your family. And I just want to share two memories that I made while we worked together, and it's also supposed to be funny. You know, it's taken a bit out of context. So the first thing I remember is when we met, this was on a CN day. I think we had this CN dinner, and I think this was the time when Selma left, and you know, this is where I came in, and he said, "You are handsome, can you be my supervisor?" I was really a bit confused, and then next day I talked to Bea, so Bea, what's going on? And okay, and this is how I joined your team. And I really enjoyed it. I mean, I think we have been working very efficiently and effectively together. And yeah, I mean, I can only second what Bea said. I think what really impressed me, like, yeah, how goal-directed and efficient you work. When we had meetings, you were listening. Okay, I'll do. And then already within a few hours, we would get the email, okay, I did it. Is it okay? So you really kept us busy because you were working off your task so efficiently. And I think, yeah, this is really a strength that you should keep, to work so efficiently and so in such a structured way. And the other thing, I think this needs to be shared. I mean, just to tease you, it's almost this infamous statement where he told me, "I'm not a logical person. This is difficult." But it's really funny because I haven't heard this before in a scientific context. But I think you have been really wrong because in the end, I mean, this was, I think, when we talked about the paper writing and the introductions, and which I really love. I really love the writings, and I remember it was difficult for you at the beginning. But now looking at your thesis, I mean, you have published 2 papers by now, and yeah, I think you have really shown that you can do this, that you can do this really well. And yeah, I think what I wanted to stress is also something I really appreciate. You are very honest and very direct. You have a very clear view of what you want, what you need. And also when we talked about your future as a job, you said, "Oh, I need a job, and for the job I need to make this expertise. I want to learn this." And it's very clear and concrete, which, yeah, also kept us busy sometimes. But again, I think this is really a strength of you that you should really keep up like this. Yes, and finally, I mean, something that many know, but I think this should also be highlighted. I mean, you have grown not only as a scientist, but also as a person. You came here to a completely different culture. In the Netherlands, I think the life here is quite different from life in China. I've never been to China, but I guess it's quite different. And but yeah, you mastered this really well. You got married here, in the Netherlands. The baby is coming now, and I think, yeah, you would say, okay, at a given age, this is what people often do, but I think it really makes a difference if you do this in a completely different culture. And then you're working in Bea's Power Lab at the same time. I mean, to handle all this at the same time, I think, yeah, this really deserves to be highlighted. So, yeah, I think you can be really proud of what you have accomplished. And yes, we are too. So I'm also speaking on behalf of Bea here. And thanks for your efforts, for the energy that you put in the project. And then, yeah, we wish you all the best for the future as a mother and also as a scientist.
Thank you.
And dear Dr. Lu, also on behalf of Maastricht University, I congratulate you with the degree you have acquired. And on behalf of all of us, also congratulations to the beautiful news we just heard. And of course, this is the moment I can use this. I hereby close this academic session, and thank you all for being here, and thank you.
Thank you.
All right.